So last class, what was the revision we have done? What was the revision we had done last class? Am I audible to you?
Ma'am, up to Okapi model.
Which model?
Okapi.
Okapi model. Okay.
Okapu.
Yeah. Okay, fine. So only two more chapters left for revision. One is classification and the other one is clustering. So for classification also, like last time, we are going to see only the important uh, topic for your exam purpose. Okay. So let us see. Uh, that is your vector space classification. So in vector space classification, here we based on real value vectors. So we based on real value vectors. The classification is based on real value vectors. So we have normally we are going to study two types of classification methods here. One is Rockwell classification and the other one is KNN classification. So KNN, K nearest neighbor. So these two classifications we will study. So Rockwell classification and K nearest neighbor, the difference is given here. So we will come to the classification. So as you can see in the diagram, the line which I have drawn here to separate China, UK and Kenya, these lines are known as decision boundaries because with this boundary only we can differentiate, we can classify that uh, the different classes. Okay, so with this concept we are going to use in our text classification, text or document classification. As are given, so we will come to the example for Rockwell classification. So here I have four documents along with the information in the documents. Information in the sense the documents which contain some words, some terms. So the terms or the words in the document are given here. Then we have a test set document also. So what we are going to do is, based on these four documents given here, we are going to assign a class to this document D5. Document D5 is initially given here without any class label, without any classes being assigned to D5. We are going to assign whether it is a yes class or a no class. Yes, in the sense it is China class, and no, it is not China class. So initially this table will be given for your exam. Then what you have to do in the next step is you have to find out the here you have to no, not this one. You have to find out the IDF. So this is the first step. Okay, step one. Step one is to find out the inverse document frequency. IDF is nothing but your inverse document frequency. And we already learned how to find inverse document frequency using the formula given here, log n by DFT. So DFT is document frequency for the term in the document. Now, can it is from the example given here, we have four documents, so n equal to 4. And document frequency for Chinese. So document frequency for Chinese, that is number of documents Chinese is present. So 1, 2, 3, 4. So in 4 documents Chinese is present, we are going to count the number of documents. So like that, all the IDF values are calculated here, and taking this value, we have constructed the second step. The second step is TF score. TF score is normally this is calculated, the TF scores are calculated using this formula given here. Okay, so if your term frequency for the term in the document is greater than 0, if the term frequency, this is not a document frequency, okay, we are going to count the term frequency. So if the term frequency for the term in the document is greater than 0, then you have to use this formula for calculating the new TF score. So this will be the new TF score. So if your term frequency is equal to 0, then no need to calculate because it will be 0. The frequency will be 0. So using this, we have calculated and we have the new TF scores. That is what it is substituted here. These are all the new TF scores. So why this 0, 0, 0? Since the term frequency is 0, that means the particular term is not present in the document. In that particular document, then we are going to put 0. Since Japan, Tokyo, Macau and Shanghai is not present in D1, all these TF score will be 0. Chinese is present in D1, Beijing is present in D1, so their respective TF scores are calculated and we have put here. Likewise, we have calculated for D2, D3, D4 all the new TF score. So we now have new TF score and also we have our IDF scores. So now the third step is to find the TF IDF. Third step is to find TF IDF, term frequency and IDF weighting. That is term frequency multiplied by the IDF scores. So that step is given here. So new TF IDF score. So we are going to multiply the new TF score along with your IDF value. So after substituting the TF and IDF, and for the second part for D1, you see in the Beijing part, I asked you to change this one. Okay, so 1 is your TF and 0.60 is your IDF. So this you have to change. So TF you have to write in your left side, IDF you have to write in your right side. Okay, otherwise you can write 0.60 into 1. That thing also you can do. So the values you got here, all the new TF scores along with the IDF values you have calculated here, those values will be multiplied and you got this table. Okay, so this TF IDF score is you have calculated for the documents, you are going to calculate for the query also. So before calculating that for the query, we are going to represent, now this is document, we are going to represent as vector because this method is vector space classification method. So we represent documents as vectors. So the symbols are changed here, D1 vector, D2 vector, D3 vector and D4 vector. Initially it was documents, D1 document, D2 document, document D3 and document D4. Now, since we represent this document as vectors, the symbols are changed. Okay, it's nothing but just the symbols has been changed. Now, see, we got the values here. and you can see the calculation. When we convert documents as vector, you have to calculate using this one. Okay, so see the right side so that you can understand properly. For D1 Bayesian, document vector for Bayesian. So this is your IDF value, or this is your TF IDF score value, and divided by this one. 1 second, for D1, where is it? Yeah, this one. For Bayesian, 1 into 0.60 is 0.60. Okay, so 0.60, that value is used here for calculation. This is your normalization. Normalization, we have done this and we got 1 for document vector. Similarly, you can see here the explanation given down here. D1 vector for Bayesian. So TF IDF score is 0.60, and since all other values are 0, we consider only 0.60 for document D1. So D1 you can see here 0 into 1.77 is 0. For Japan in D1 0, for Tokyo in D1 0, for Macau in D1 0, for Shanghai in D1 0. So we have only Beijing. So only in Beijing part the square value is given here. Okay. So after this calculation, we got here document vector of Beijing in D1 is 1. Like this, you have to calculate for all the terms in the documents. So after calculating only, we got this final table. Okay, so we got this final table. So these things we have to calculate for the query also. The explanation, the same thing only. So one second, one step is missing. Calculating, where is it? Okay, centroid is here. Okay, centroid, mu C. So in mu C, C stands for China. Since we have China and not China, there are two cases here. So that thing we are going to calculate here. So let us first find out the centroids. Here we are going to find the centroids for both the cases. Okay, for both the cases. That means suppose you take Chinese centroid for Chinese in China classes. Okay, and centroid for Chinese in not China class. Like that you have to find for all the terms. So for Chinese you can see here, this is since we have 3 yes classes, then 1 by 3. So what are the documents for yes class? D1, D2 and D3. So those vectors I have substituted here, and calculation is in 1 by 3, 0 plus 0 plus 0. As you can see here from the table. Okay. So for D1, Chinese is 0. For D2, Chinese is 0. For D3, Chinese is 0. So that's why we have here, where is it? Here 1 by 3, 0 plus 0 plus 0. Similarly, we calculate for all other terms, then the values are given here. And as I told you, there are two conditions for for China classes. We have calculated all the centroids, and for not China, we have only one class. So for that class also, we are going to calculate for the terms in it. So D4 is the only not China class. So we got 1 by 1 for D4. For Japan, it is 0.71. So you can check it from the table. For Japan, in D4, it is 0.71. It will be same with Tokyo because it occurs only one time. It occurs only one time. So 0.71. So we have calculated the centroids. So thus those centroid values are written here. Okay. For China class and for not China class, there are two conditions. So for those two conditions, it is given here the centroid values. And after finding the centroid value, we have to find the distance from the centroids. Okay, distance of what? Distance of the test documents from the centroids. So distance calculation is done here. We got 2.4 something 41. The same case we have to calculate for C2 class, which is North China class. The distance calculated test document from the centroid, and it is 0. So 0 means it has a minimum distance. Minimum distance means maximum similarity. So we are going to assign our C2 our D5 into C2 class. Okay, since our North China class has the minimum distance with D5 test document, D5 is assigned to our North China class. Okay. So this is how our Rokyo classification has been done. And similarly, for this Rokyo classification, we have hyperplane calculation also. For using hyperplane calculation, we use this formula. So we substitute all the values here. This is for China 1, C1 means China class, and C2 is not China class. So we calculated the hyperplane. So subtracting the values, those two centroid values, and we got this one. So this, what we have to do in next step is we will be performing a dot product with all the document vectors, with D1 vector, with D2 vector respectively. Okay. So all the vectors we have calculated, and we compute B. So B is some constant. So B calculation is done using this formula 0.5 into centroid vector for C1 square and centroid vector for C2 square. So that calculation done here, taking the values from C1 and C2, then we got around minus 0.33. And finally you make a conclusion after comparing the value of B with each W vector along with the document vector. So those values, those documents in C class, that is in China class, are above the hyperplane, and those documents below the hyperplane, they are in North China class. So like that we have to conclude for Rokyo's classification. And one more classification is there in vector space classification, that is nothing but our KNN classification. So this is KNN classification. It can be applied in many areas, but here we apply in text classification. So these things you have to remember properly, because KNN classification can be done in certain ways. So here for our purpose, we are applying KNN in text classification. So text classification, let us see how, one example. One second. So KNN for text classification. So it determines the decision boundary. So this determines the decision boundary locally. So how we will see with an example. So for KNN, we assign its document to the majority of class of its K closest neighbors, where K is the parameter. K is nothing but a parameter. So this parameter K in KNN is often chosen based on experience or knowledge about the classification problem. So after performing certain experimentation, we chose the K value. So that based on that experiments, normally K value will be odd numbers. So the desirable value for K will be odd numbers in order to make ties less likely. Otherwise, sometimes you may have same result. You may have obtained same result. So we use the suitable value for k is odd numbers. So k equal to 3 and k equal to 5, these are the common choices, but can be larger values too sometimes. Okay, so this things which I have read out now, these are important. That's why I'm reading this out. Why k value is assigned to odd numbers and like this. Okay, and what is k in KNN, like that. So example, the same example, Rockio's example, where this is the representing document as vectors, that table here. So we just take that table. Initially you have to calculate all those things above. You have to calculate the IDF, you have to calculate TF score, you have to calculate TF IDF score, and finally you have to calculate this centroids, and also this is the your what is this, representing document as vectors. So that table I'm taking directly here, and after this we are finding the distance. So this is the last step. So I have, since we have the same example, we use the same example for calculation. So we have sorted up all the other calculations, and we are taking the document as vector representation table, and from this table we are going to find the distances of the test document from the training documents. So D1 and D5, D1, D2 and D5, D3 and D5, D4 and D5. Like this, we have to calculate the distances of the test document from the training documents, and we will find the nearest or the minimum distance document. Okay, so D1 and D5 using Euclidean distance, it is calculated. We got around 1.417, and for D2 and D5 we got around 1.417. Similarly, D3 and D5 also same value. D4 and D5 is 0. So D4 and D5 is 0. That means D5's nearest neighbor is D4. And using 1an, considering k equal to 1, if we consider k equal to 1, that means we are going to find the absolute distance. So using finding this distance, we can assign D5 to North China class, because D4 is North China class. So directly we can assign our test document D5 to North China class when k equal to 1. When k equal to 1. But if k equal to 2 or k equal to 3 or 5, then accordingly we have to calculate. So for the same example you can calculate, but for your understanding, the example is given here. You find the absolute distances. So suppose if you find D1 and D5 1.4, D2 and D5 1.1, D3 and D5 1.0, D4 and D5 1.0, then you have, when k equal to 3, you have to take 3 nearest neighbors. Okay, so you have to take 3 nearest neighbors, and you take average for this, or you take the majority of this. Okay, majority of the distances, or you take the average. Sometimes if there is no majority, then you have to take an average of these 3 minimum values. Or else, if you have a majority value here, then you can take the majority value. When k equal to 3, you have to take 3 nearest neighbor from the test document. This document is D5. So the 3 nearest neighbors are D2, D3 and D4. So now taking the majority class among the nearest neighbor, we get D3 of C2 class and D4 of C2 class. So when you take majority, so D5 we will be assigned to C2 class, that is North China class. Okay. So this is just a sample how to calculate when k equal to 3 or when k equal to 5. But normally the preferable value of k is k equal to 3. So this is about your Rockyos classification, your KNN classification. And the last one, I think recently we have done, but anyway we will go through once for clustering. Clustering, where is it? One second. Clustering. So clustering is grouping of similar objects, and in clustering we have two types, as I told you last class: flat clustering and hierarchical clustering. Flat clustering normally deals with your k-means algorithm, and hierarchical clustering example you can study your agglomerative clustering and diffusive clustering. Okay, so in hierarchical clustering, those type of clustering methods will create a hierarchy of clusters. Okay, so they will create a hierarchy of clusters. So those two examples, I will show you those two examples. Where is it? Where is the clustering example? So K-means clustering, their example, I haven't shared yet. Okay, okay. One second, let me show you K-means. Where is it? Hierarchical clustering. Okay. So you can see this, the same example which we have seen last class. So there are certain documents, and this is your frequency matrix, document term frequency matrix. So based on the frequency, you have to find the distance. Okay, D1 and D2, D1 and D3, or D2 and D3 distances you can find based on the frequency. But in K-means clustering, initially there should be some centers randomly chosen. So we have, in this example, we have chosen D2, D5 and D7 as the initial centers. Here also we are assuming the parameter k is 3, so there will be 3 centers, so 3 seats or centers. So from these centers, the remaining documents you are going to find the distances. Okay. So D1 and D2, D3 and D2, D4 and D2, D5 and D2, like this. You have to find the distances using Euclidean distance. Euclidean distance here, formula is given here. We have calculated the distance D1 and D2 because the distance is 2. So all those distances are here. Okay. So D1 and D2 it is 2, D1 and D5 it is 2.6, D1 and D7 it is 2.2. So you select the minimum distance like this. D2 and D2 it is 0, D2 and D5. So like this you find all the distances and check the minimum distance. So based on the three distance you got here, 2.6, 2.2, 2.0 is the minimum distance. So 2.0 belongs to D2. D2. So this D1 will be moved to D2 like this. Now you check for another one. So for the D2 it remains the same because we have considered D2 as initial cluster. So now D3. D3 we have three distances. The distance from D3 and D2 is 2.4, D3 and D5 is 3.0, and D4 and D7 is 2.6. So you check the minimum distance. After checking the minimum distance, here we got 2.2. 2.2 you check here, it is the minimum distance is 2.2, which belongs to D7. Then you can move D3 to D7. So now we have moved D3 to D7. Like this, check the minimum distances and move the documents to the minimum distance clusters. So in D2 there are 5 documents, and D5 there are 2 documents, and D7 there are 3 documents, like this. So these are the number of observations. This is the number of clusters which you have randomly chosen initially. Then so using this same example, we can continue with your agglomerative and divisive. Agglomerative clustering is bottom-up clustering, and divisive clustering is top-down clustering. So in bottom-up, let me share this. See here, you will see this example. So the algorithm says assign each observation to each on cluster. Compute the similarity. You have to find the distances between each of the clusters and join the most similar objects. Repeat this until there is a single cluster left. So here in bottom up, initially when you start, all the documents will be a single cluster. All the documents will be a single cluster. So you have to group this by checking the distances between them until it forms a single cluster. That is bottom up. And top down, you are going to start from a big cluster where it contains certain other documents which is being grouped together. Then you have to just move down according to the similarity. Okay, similarity here, which is calculated by finding the distance until you get single individual clusters of the documents. That is top down. Okay, one is bottom up and the other one is top down clustering. So this same example, when you come to this one, moving the clusters, you can see the example here. So this is the, one second. Yeah, this is the example. So bottom up, you see agglomerated. You have all individual clusters here because we are considering the individual documents as single clusters. So by finding the distance, what do we notice? That D2, D1 is being moved to D2, then D6 also be moved to D2. So those documents being moved, say D2 has 5 documents, D3 has another 3 documents, and D5 has 3 documents, D7 has 2 documents. So here we have 2 documents, we have 3 documents, we have 5 documents based on the similarity which is calculated by finding the distance. So being moved together into a cluster, being moved together into a cluster, and the third one also being moved together into a cluster. And finally, all these 3 different clusters we move into a single cluster. This is bottom up agglomerated. Just opposite of this, it will be top down. We are going to start from top here. All clusters, all individual documents in single cluster. Then by breaking it down like this until we get individual clusters. So this is hierarchical clustering. Okay. So for your exam, up to this will be your portion. Portion will be from after midterm. After midterm, I think vector occupy was there after midterm, or I forgot what was midterm syllabus. It was occupy was there in the midterm.
No, ma'am. After vector space, it was after the midterm. Vector space.
Vector retrieval model.
Yes, ma'am. It was after midterm.
Okay, okay. So after that, until this clustering, so will be your N-term syllabus. And Viva, I think your exam will be starting from 17. Timetable, I don't know whether it is already circulated or not, but if I get, I will share it. So by 17, we are going to start the midterm, and before by 25 or 26, we are going to finish your end term. So before 26, I'm going to complete your Viva. Okay. 23rd and 24th, I have your B final year presentation. So maybe on 25th or 26th, I'll finish your Viva, your final Viva, interim Viva. Okay. Okay, I'll take your roll call. So the revision is up to this. We have completed the revision. And in calculation or in any part of the topics which you don't understand, you can inform me. You can call me up or you can ask me any doubts regarding this ISR. So roll number 1,
Present, ma'am.
roll number 2,
Present, ma'am.
roll number 3,
Present, ma'am.
4, 5,
5 present, ma'am.
6,
Present, ma'am.
7, 8,
Present, ma'am.
9,
Present, ma'am.
10, 11, 12, 13, roll number 13, roll number 14, 15,
Present, ma'am.
16, Herojit Freebum, 17, 18,
Present, ma'am.
19, Jagdev, roll number 20,
Ma'am, roll number 13 present, ma'am.
roll number